So good morning to all of you. As usual, we will start with a small simple experiment in physics. I hope you can see this. What is this? This is a meter scale, right? You all would have used it in the lab. And I have here two 50-gram weights. I put some sellotape so that I have just loaded on one side. Now I want to balance it with my two fingers. I am not holding it. I am not holding it. I am only balancing it. Right? Now what I am going to do? I am going to move only this finger, not this finger. But still this is slipping here. You can see that. I am only, see here, this finger is moving. Now this finger starts moving. Then you see, both of them alternately move. And finally, I end up at some point. What is this point? You all know it. This is actually the center of mass, right? So I will do once more. I have your beam which is loaded at one end and I try to move one of the fingers. For example, this finger. I move only this finger. But after some time this finger becomes more difficult and slips on the other finger. See here? I don't know whether you see the thing, what is happening. Okay? So I always end up at the center of mass. I'll just do one more time so that you see it. Even if I do it fast, you will find I'll always end up at the center of mass. Okay? Now what I do? I will remove this. So I removed the mass. So there is no mass now. Now I will do the same experiment. Where you think I will end up? Right at the middle, right? Because the center of mass now is at the center. It's a symmetric piece and therefore I will end up at the 50 centimeter mark. You can see that. Before it was somewhere here. Now it is, I am doing the same experiment. You can see it alternately slips and finally I end up at the center point which is around 50 centimeter. Can I explain why this is happening? Why is it happening in this way? It is all known physics. There is nothing which involves some quantum mechanics or matrix multiplication or some complex functions, nothing. It is all things that you already studied in your maybe +2 or earlier. Okay? I will briefly explain to you. If this is the thing, if I put one pivot here, and this is my center of mass point, and if I don't support it here, this is the center of mass. Now if this distance and this distance are the same, this mass of this beam will be equally supported here, here. This mg is happening here, where m is the mass of the beam. You have a reaction here, you have a reaction here. They will be equal if I put the fingers at the two equal points. When I am here somewhere nearby, what happens? If I support it here, then what will happen? The reaction, more mass will be supported here, less will be supported here. So the reaction here will be slightly more. I hope you understand what I am saying. Now we all know friction. What is the frictional force? Is given by mu n. You have studied in your 11th or 12th. Frictional force is equal to what is mu? The coefficient of friction between my finger and the beam, in this case, between the beam, that is the meter scale, and my finger. So, and n is a normal reaction. This is what we call n. So when I am away from the center of mass, the reaction force is less compared to when I am close to the center of mass. Now if I start moving deliberately, where the reaction force is less, there it will slip easily because the frictional force is less there. Frictional force mu into n, because the n is small, it will start slipping here. It will start slipping. But when I come to very close to this, you will find this and this will be almost equal. One could be slightly greater. Then you will start, this will start slipping, and then this will start slipping depending upon which is higher. And as I come close to that, both of them I meet at the center of mass. So it is basically a consequence of the frictional force, and because the reaction now is a function of distance from the center of mass, you find when there is more reaction, there is more friction there compared to the other one. That is the reason. So it's a very simple thing, but I suggest you try to do it yourself. When you go next time to the physics lab, you should take the meter scale and do the experiment yourself once, because you have to experience to know what I say. Because you will think always that I am trying to move my hand finger deliberately. No, I just move in the normal way. Automatically it slips here, now it slips here, now it slips here. So finally I end up here. So this has to be experienced if you really want to understand the simple physics behind it. Incidentally, you also know another similar problem in friction, which we all experience at every stage. What is that? If I have a box, it is a box I want to move. So what is the best way to do? Should I pull it in this direction or push from this direction? I can push or I can pull. Which will be easier? Whether the pushing or the pulling. It is also decided by the physics of the situation. Why? So if you have a person standing and if he is pushing this direction, then what happens? mg is down, the weight and this force can be resolved in this direction and in this direction. Only this component of my pull is used for moving it. There is another component here which is corresponding to this force which I give. If I call this F1. So some component of F1 will be here. What is the effect of this? It will reduce the net pull of the gravity. So the net pull here is mg minus, if I call this n1. So you find the reaction force will be now different. Actually I can put it the other way. N minus mg, that will be the net reaction force. N minus mg will be the reaction force, and the frictional force mu times n, because n now is decreased due to the, I'm making some mistakes, sorry. So what is n? N is the component of F1. If this is theta, this is F1 sine theta. So mg minus F1 sine theta is the normal reaction. The F1 sine theta comes from my pull. I hope you see that. This is F1 cos theta, this is F1 sine theta. So mg minus F1 sine theta will be the net force here, and the reaction force should be equal to that. So now, if I push in the opposite direction, if I do like this, then you would see it will be mg plus F2 sine theta in that sense. That will be equal to n. Because if I push like this, I can resolve that in the two directions. This is responsible for moving the block. This is actually a component of this push in this direction. So it is adding mg along with this F2 sine theta should be equal to the reaction force. Therefore you find in one case it is minus, in the other case it is plus. So which reaction force will be more? So n1 will be less than n2. Therefore mu n1 should be less than mu n2. Therefore you find I will have to oppose only less friction when I pull, and therefore it is easier to pull a heavy object than push. When you push, you are trying to push it towards the ground, so that increases the vertical force, and therefore the reaction force increases, friction also increases. If I pull like that, the reaction force decreases, therefore friction also decreases. It is much easier. You would have seen when you go travel in a train and all that, when you pull a trolley, if you pull the trolley, it is much easier. When you push the trolley, it is much more difficult. So that again comes from the simple concept of friction, which I already explained using the meter scale. Okay. Now let us move on with our discussion that we have been having last time, and you all know what it is. That is, I was discussing about polar coordinates. Right? So I did lot of things. I want to quickly recapitulate whatever we did. This is x, this is y, this is z. Any point P can be represented in Cartesian system as three quantities x, y, z, which are all the three components of this vector, if you want to call it position vector. Okay, we call this, I think, as rho, and I can also find out the phi, which is the angle, which I think I used only the two-dimensional polar, no. Every time I make this mistake. X and y, rho, so this becomes the x coordinate is nothing but this distance, the y coordinate is nothing but this distance, and therefore you find this distance by the trigonometry. We know rho cos phi, and this is rho sin phi. This I have already discussed all these things. So my x is equal to rho cos phi, my y is equal to rho sin phi, and my rho is equal to x square plus y square by Pythagoras theorem. X square plus y square is my rho square. And then how do I get? I know tan phi is equal to y by x. Therefore, I can say phi is equal to tan inverse y by x. So they relate x, y Cartesian coordinate with rho phi of the polar coordinate. Here rho and phi are related to x, y in the reverse direction. So these are important things that we should remember. In addition, we also saw that I can take a E rho and E phi, which are all the unit vectors. So I can take a small unit vector in this direction, and phi is the vector in the direction of phi increasing, E phi. E phi is a unit vector in the direction of phi increasing. Phi, when it increases, it has to increase like this by moving. So tangentially I should draw the unit vector. And similarly, this will be my E rho, what I have shown, unit vector. So it is along the direction of rho increasing. This we saw last time. I can relate these two. What is E rho? Is cos theta Ex plus sin theta Ey, and this is minus sin theta Ex plus cos theta Ey. So these things I explained to you last time. I don't want to go into the detail, otherwise we lose a lot of time. So we have seen that, and we also saw they are again they are at 90 degrees, E rho and E phi. How do you know? Take a dot product of these two. If the two vectors are perpendicular, if you take the dot product, cos 90 becomes 0, therefore it should become 0. So you can check that yourself. And so I will say E rho dot E rho is equal to 1 is equal to E phi dot E phi. E rho dot E phi is equal to 0 is also there. And then okay, these are important results that we also will be using. Similarly, I can find Ex, Ey in terms of E rho, E phi. That will be the opposite of this. I'll write here. Ex will be cos theta Ex E rho minus sin theta E phi, and Ey will be equal to minus plus sin theta E rho plus cos theta E phi. Okay, that is what I will get. I will get cos theta sin theta minus sin theta cos theta. Cos theta minus sin theta cos theta. So if I put it in matrix form, you know that this transformation matrix and this transformation matrix are nothing but transpose of each other. Okay, if I take that, transpose means what? Except diagonal, all the other things I swap from here to here, from here to here. So you find plus sin theta comes over here, minus sin theta goes over here. Swapped. Okay. So this is the relationship between E rho E phi, and if I want to represent, we also saw another thing, maybe you remember that, and what is that? That E rho, if I want to represent any vector, some A, I have to say component along the rho direction into E rho plus component along the phi direction E phi. This is a normal way we write, even in, for example, Ax Ex plus Ay Ey plus, that is what you will write in the two-dimensional case. This Ex Ey is your familiar Ij. Instead of Ij, I am using Ex Ey. I told you already. So you can write it in terms of E rho E phi also. The same, both are same vector, except that the components are different because I am using a different coordinate system. Right? Now, what about my radius vector? Radius vector is some r, usually we represent r. It is nothing but if the magnitude is rho, we have said. So rho tells me the magnitude of the vector, E rho tells me the direction is along the E rho, rho, right? So this is the thing. Now you find they have component phi, here there is no component in the phi. So does it not depend on phi? Yes, it depends on phi, but you should remember E rho is nothing but E rho of phi. E rho itself is a function of phi, because if I go along this direction, my E rho is in a different direction. If I go along this direction, my unit vector is in this direction. So you find the E rho direction itself can change with phi. Therefore, this E rho contains the phi variation for any of the vector, radius vector. So that is why it is only having one component, rho E rho, even though E rho contains all the information about the phi. We also saw if I differentiate, this also we saw. What will be this? I have to differentiate this with reference to time. You find I should have used all of them phi. Sorry about that. I should have used cos phi. Okay. Dou E rho by dou t, if I do, cos phi will become minus sin phi. This will become cos phi, and therefore it will become like this, and therefore it will be phi dot E phi. This we have done before. Okay. That is, this will, when I differentiate this, this will become like this, minus sin phi plus cos phi, so it will be like this. But there will be a phi, d phi by dt, that also will come, and that d phi by dt I call phi dot. You know that. A dot means differentiation with reference to time. So phi dot E phi is what I get. Similarly, if I find out all these things I have done last time, if I do E phi by dt, you would find it is minus phi dot E rho. So if you differentiate this, you will get that. So this result we should remember. So E rho dot is equal to phi dot E phi. E phi dot is equal to phi dot E minus. There is a minus sign, that is important. So this we should remember. Once we remember that, now I can go for what happens to the velocity. in a Cartesian system is equal to some x Ex plus y Ey plus z Ez. So if I want to find r dot, that is dr by dt, find that is velocity. Velocity is equal to dr by dt. That is what it means when I put a dot there. And so I can say it is nothing but x dot Ex plus y dot Ey plus z dot Ez. This we know, because only this will change with reference to time, this will not change. Ex is always in the direction of x, always. Similarly, Ey is always in the direction of y, and therefore this Ex Ey will not change. But the same is not true here. So if I want to find out, I will again use only the two dimension. So if I want to do here, what I should do? Here it will be d by dt of rho e rho. That is what it is. Instead of r, I should put rho e rho. And what will be this? I will write at the top. If I do that, so V is equal to r dot is equal to, first I will use d rho by dt, e rho, plus rho d e rho by dt, because e rho itself is a function of time. So if it the object is moving, if the object is moving in some direction like that, at every point the e rho changes. So I have to find out what is the rate of change of e rho also to get the full information about the velocity. And what is d e rho by, is nothing but e rho dot, and that is phi. So I can substitute that. This I will put it as rho dot e rho plus this one is phi rho, which is already there. This is phi dot e phi. Now, what is phi dot? We all know phi dot is nothing but angular velocity, d phi by dt, omega. We know it by a different name, angular velocity, omega. So this is omega. This is radius vector. So this is something like r omega, rho omega. Rho omega is the linear velocity at the point. Tangentially, this is the velocity, tangential velocity is given by r omega. This is the velocity along the rho direction. The body can have both in any given, unless it is going along a circle, you can have both components, the radial component of velocity plus the tangential component of velocity. Both are important. So this gives the radial component of velocity, and this gives me the tangential. So this is what we should remember. It has got both. Okay. Once we get velocity, then what we can do? We can go to the next level. We will find out what is acceleration for the same particle which is moving. It is nothing but dv by dt, or r dot, we will give on r double dot. R double dot means what? D square r by dt square. That is what it means. Instead of that, I write r double dot. Okay, what is that? How do I get? I will go through the same. Now I have to differentiate the whole thing. That is V. So that will be equal to, first I will differentiate these two. Remember, this also will change with time. That we should always remember. Otherwise, we will make a mistake. So first, rho dot. If I differentiate with reference to time, what will happen? It will become rho double dot, and keep u. It is like d by dt of uv, du by dt v plus u into dv by dt. That's what I'm doing in the differentiation by parts. So rho double dot E rho plus rho into rho dot into E rho dot. I have to differentiate this. This will be the first part. Okay. Then the second part is this 1, 2, 3 items are there plus this one if I differentiate rho dot, rest of the things I can keep as such plus now I will keep this and differentiate phi dot, then it will become phi double dot, then E phi. Then I will have third one which is keep rho phi dot as such and then only differentiate E phi. This is what I get. Now I will make use of these two relationships here and then simplify. So what will happen? My A will become equal to rho double dot E rho. So what is E rho dot? Is phi. So plus rho dot phi dot E phi. So I replace E rho dot by phi E rho dot. Phi dot E rho dot. That's what I have done. Plus rho dot phi dot E phi. Already it is here. Okay. Plus rho phi double dot E phi. Now here E phi dot is there. E phi dot is minus phi E rho. So minus rho phi dot another phi dot E rho. So this will be phi dot square E rho. That is what I get. Now I group them together. I can group them together and rewrite my acceleration part neatly. What is that? Acceleration is equal to, there is E rho here, there is also E rho here. So I will say rho double dot minus rho phi dot square both along the E rho direction, right? I hope you can see that. Plus I have rho phi dot phi double dot, this one and these two plus 2 rho dot phi dot in the direction of E phi. So I find this is the acceleration, this is the velocity. When I differentiate, this is what I get as my acceleration. So you should remember, but it looks very complicated. This has got so many terms, but everything is understandable. Here we have understood. This is the velocity along the radial direction. This is the velocity along the tangential direction. At any given position, it can have one component along the tangential component direction, one along the radius direction. That is what it means. So you know what is this I called r omega, if you remember, that is the speed along the path, and rho dot is the along the radius vector, along the direction of the towards the origin. So that is what it is. Similarly, I can understand all these things. What are those things? What is this? Rho double dot is the acceleration along the E rho direction, radial acceleration, acceleration along the radial direction, rho double dot. It is along the E rho. Rho double dot is acceleration, d square rho by dt square. Rho phi dot means phi dot I already told you is omega, so it is r omega square. Instead of rho, you can, if you think r, it is omega square r. And what is that? That is called the centripetal acceleration. For any curved motion, if you want to have a curve, then there should be a acceleration towards the center. Centripetal means center seeking. Therefore, this is a must for any curved path. If it is on a circle, we all know it. There is a centripetal force, center seeking acceleration. So that is what it is. What is this? Rho phi dot, phi double dot. Rho phi double dot is the acceleration along the phi direction, that is tangential. Tangential acceleration. This is the thing. Then we have one more term. What is that? 2 rho dot phi dot. This is a new force, new acceleration that I am getting. What is it? This is called Coriolis acceleration. So all the 4, 1, 2, 3, 4 can be understood. Rho double dot is the acceleration along the radial direction. Rho phi dot square is actually the centripetal acceleration which is required to make it go along a curve. Rho phi double dot is a tangential acceleration in the direction of phi dot phi. 2 rho dot phi dot is a Coriolis acceleration. Everything is understandable except this. This is not understandable. But this is very easy to understand. I will explain to you. See, I have a disc, circular disc attached to a motor. This is a motor. And it is attached to the disc. So if I now switch on the motor, what will happen? This disc will rotate like a gramophone plate. It will keep on rotating in the horizontal plane through a vertical axis. It will keep on running. That is what, this is the top view, this is the side view. So this will be rotating in some direction like that. This will be going round and round. Now what I do, I take small marbles or lead shots, ball bearings, I put it in some paint or ink, and then I use a small plate here and drop at the center. So I put like this and then drop the ball. So when I am sitting, when you all sitting in the lab, if you observe from the top, you will find that lead shot will go like this. While it is running, it is continuously running, but still you will find it will just go out like this, that marble or the lead shot. Any number of times you do, it will be there. Now what you do, you stop and see what is there. If you see here, you will find it will be this spot. Why? Before it goes here, this should have turned. So you will find this plate will come here. By the time this travels from here, this point will come here. So if I put a white paper on this and perform the experiment, you will not get a straight line, but you will get a curved line. Why is it? Because the plate is rotating, as simple as that. So a person who is standing here, for him this rotating platform is his world. For the person who is standing here, we are all outside this table. For us, this is an inertial frame. Earth is an inertial frame for present purpose. So now you find the person here observes a motion which is very complicated. So what he will do? He will say, hey, there is an additional force which is responsible for taking it through this direction. And so this force we will call, this is Coriolis force after the person who found it. So this is a very important force for all of us. This is a non-inertial frame. What do you mean by non-inertial frame? Any frame which is accelerated with reference to us is a non-inertial frame. If any frame is having a uniform velocity with reference to our frame, then that is also inertial frame. In inertial frame, Newton's laws will be valid. In a non-inertial frame, Newton's laws need not be valid because there is an additional acceleration that will come into the game. So just because he is in a rotating frame should be under constant acceleration. Just now I talked about centripetal acceleration. Without that you cannot rotate, and therefore this is an accelerated frame, and the person inside the accelerated frame will observe an additional fictitious force which he calls Coriolis force. It looks as though it is fictitious, but in reality, as people living on this earth, we experience Coriolis force, right? So when winds move from the southern hemisphere, because of the rotation of the earth, they will divert, they will go in a curved path. Similarly, winds coming from the northern hemisphere, they will also go along. That is why you get different kinds of cyclone and all that. So you find this for us who are on a rotating frame right now, we are all on earth which is rotating all the time about its own axis as well as about the sun, and therefore it is an accelerated frame, even though for most purposes, for a simple purpose in the lab, we will consider earth to be a non-inertial frame. Okay, we will consider earth to be an inertial frame, inertial frame. We all know that itself is rotating about itself as well as about the sun, and therefore indeed a non-inertial frame. So when you look from outside, you will see the direction of the changing from northern hemisphere or southern hemisphere is because the earth is rotating, very simple. But the people on earth will find some fictitious force is responsible for the diversion of the wind, and therefore they impute a new force, and that is what we call the Coriolis force. So now I have briefly explained to you what the Coriolis force is. This is a very good experiment. Normally I show a demo also, but now I am not showing because we don't have ready. So you find there is also this, actually the Coriolis force will be, this will be the actual force, Coriolis force. I am not going into the detail, you can derive this, okay. So that if you take the magnitude, it becomes rho phi dot, rho dot phi dot, rho dot is V, phi dot is omega, 2 V omega, 2 V omega is the magnitude, okay, that's what we are getting. Okay, so we have now got all the things. This is for a general scheme. Now I want to take one specific case. What happens when rho is equal to a constant? There is something moving, and it is moving such that the distance rho is always a constant. That means what will be the type of motion? Circular motion. Because if the radius is a constant, then it has to go along the circle. So it is going to be a circular motion. If rho is equal to constant, what will be my rho dot? Rate of change of rho. Rho is not changing, it is a constant. Therefore, rho dot should be equal to 0, and same way rho double dot is also 0. Right? We know these two. Therefore, what do I have? So what happens to my acceleration? First we'll acceleration with reference to time. If I assume that will be, this will be 0, rho double dot. This will be 0, rho dot. So I have two components only, two terms, minus rho phi dot square 0 plus rho phi double dot E phi. So I get only two terms. This is there because it is rho phi dot square. This is not there, rho double dot 0. This is not there, rho dot is 0. This term will go, this term will go, only these two terms, minus rho phi dot square 0, rho phi double dot E phi. That's what I have written. Only two terms in this case. Now, what happens to, if I say rho is equal to constant and omega, that is phi dot, is also a constant. If I say both are constant, then what will happen? What is this telling? This, it is going along a circle. Why? This is a centripetal acceleration, rho omega square. That is a centripetal acceleration. What is this? While it is going along the circle, it can have an acceleration along the circle. So it can its speed keeps on increasing as it goes round, like having a stone connected to a string and you whirl to your heart. And if you do faster and faster, there will be an acceleration which is along the circular path, and that is what we say. Along the E phi direction, there is an acceleration. D phi by dt, d square phi by dt square, that is what it is, acceleration along the circular path. But if I say rho is a constant, omega is also a constant. That means what? This will also, because phi dot is a constant, phi double dot is 0. It is constant, no? And therefore this will go. So I will be left with only this. Phi dot is a constant, and therefore A of t will be minus rho phi dot square only along the E rho, which is minus. Minus means what? Opposite of E rho. E rho is going away from the origin. So minus means it is coming towards the origin, and rho phi dot square is nothing but omega square r. So this is the centripetal acceleration, so which keeps the body in a uniform circular motion. Why is it a uniform circular motion? There is no acceleration. This term goes 0 because phi dot is a constant, and so I have only one term, and that means this corresponds to uniform circular motion. So this is a non-uniform circular motion. It is also circular motion, it also centripetal, but it has got an extra acceleration as it moves. Here that is missing, therefore it is going with a constant speed throughout the circle. That is what it is. Now, so if we put some conditions like this, rho is a constant, phi is a constant, etc., immediately it becomes very easy for us to apply that to this and then try to understand the motion. Okay, so I have got a couple of problems which I can just indicate to you. Some of you will be interested, should work. I already told you the best way to learn any subject is not by mugging up whatever done in the class, but try to use the knowledge in applying to new situations. That is what an engineer is expected to do tomorrow. When you come out as an engineer, you are not asked to derive what is a Young's modulus of a bent beam. No, nobody will ask. They will tell, can you construct in this very strong river a new bridge? You cannot say this is out of portion. It was not done in the class. Because we have to now innovate, try to find new solutions. For getting new solutions, you should be very thorough with the subject, not by rote memory. You have to understand the subject and work out problems, apply it to different situations, and then become familiar with all the concepts. Then you become a great engineer. So unfortunately, this is what is missing in most of our educational system. So that is one important thing I wanted to show. So I've already got the first problem sheet with all vectors, simple things. I assembled, I will be uploading it, and then perhaps your teachers also will discuss that in the classroom. So that is very important. You have to, so I don't want you to try problem on your own. The teacher like me should work out problem here, show how to solve problem. Then only you will become familiar. You will gain confidence to solve problem. So solving problem is the most important part, because everything else is available in every book. You don't have to attend a class even. It's all there. Excellent, brilliant people have written books. I read it, I understand. What is more important? Can I apply that knowledge to new situations? If you are not able to do that, you are not a good engineer. If you have to learn that, you have to work out problems. For working out problems, I have to help you to work out problems. So I will quickly take one or two simple problems, and then we will discuss more of that when we discuss in the tutorials, where your teachers will be discussing some of the problems that I have given. So simplest thing I am giving, Cartesian coordinates are given 1, √3. So that is my x and y. Find out what are the polar coordinates, corresponding polar coordinates. You have to find out what is rho and phi. You know what is that. What is rho? This is the conversion between polar to Cartesian. And then you also know phi is, this I have written today also, tan inverse y by x. This is the phi. So I am asking a very simple application of that. So what I should do? Rho is 1 square plus root 3 square root, that will be 4, that will be 2, correct? Similarly here, this will be tan inverse y by x, that means root 3 by 1. So what that will be there? Many of you know it. What is that? That will be pi by 3. So 1 comma root 3 Cartesian is equivalent to 2 comma pi by 3 in polar. Same point. They both represent the same point. So I know this, I am applying that x square plus root 3 square. So this is 3 plus 1 4, square root of 4 is 2. Similarly here root 3 by 1, that is pi by 3. So 2 pi by 3 is the corresponding same point represented in polar coordinates. The same point represented in polar coordinates. Now I will try one small problem. So we have to work out problem in the classroom, then only you will gain confidence. That is very important for me. Find the polar equation to the circle. What is that? X square minus y minus 2 whole square is equal to 4. Very simple. Very simple. This also you know. So now they are going to xy. So I have to write it in polar equation. Then what I do? I try to find out what is my x in polar. X is equal to rho cos phi. We have seen that. Y is equal to rho sin phi. That is all I have to use. So I should say rho cos phi whole square, that is my x square, is equal to rho sin phi minus 2 whole square, y minus 2 whole square plus, is it minus is equal to 4. So x square y minus 2, y is rho sin phi, y minus 2 whole square is equal to 4. This is the equation to the circle. Now I have converted into polar. I should rearrange, square and rearrange. This is rho square cos square phi minus, I can put rho square sin square phi plus 4 minus 2 rho sin phi is equal to 4. Okay, I just expanded this. Like that, when you simplify, let me not go into that, you will find rho is equal to 4. This is actually plus. That's what I am wondering. This should be plus. This sign is plus. So you will find 4 sin phi. So this is the equation in polar coordinates. This is the equation in polar coordinates. Okay. So you find like this. I have only touched upon very simple problems because I don't want to bring a very complicated problem at the beginning. I want to try some simple problem, gain confidence. As we gain confidence, even in textbooks you will find first few problems will be simple problem, almost application of knowledge formula. Then as you go further, the difficulty level will start increasing, and that is the most important challenging part. All youngsters should face challenges in the world. That means you should also face challenging problem and try to solve. It need not necessary that you should immediately solve the problem. You should not get frustrated if you are not able to solve the problem, because it happens to everybody. No worry. But then you should at least be able to approach the solution in the right direction. You should not apply some wrong concepts. You should apply the right concept, and if you make some simple errors in the arithmetic or in the application, it doesn't matter. For myself, I will give almost all mark except 1 or 2 I will reduce. Right? So because I want to encourage people to solve problems, to face challenges, because that is what the world is outside. When you move out of the college, it is all only challenge. You don't know what to do. There will be so many things. You will find you are one of the brilliant guys. You will go there. You will find 20 other brilliant guys waiting there for interview. So unless you prepare yourself for tough world by solving problems, by understanding concepts, not by mugging up. Somebody wrote in the exam, the cations and the anions are in motion. Mugging up all the time for the exam. Then I went and saw in the book. He says, sir, it is written like that. I said, I don't know what you call motion. He said, no, it is written there. Then I went and found the anions and the cations are in motion. If you say cation, C-A-T-I-O-N, cation, M-O-T-I-O-N, for him, motion. That means he has not understood anything. He is only mugging up and he will get 5 out of 5 because the teacher is not asking him to tell the answer. He wants him to write the answer. He will still write motion, M-O-T-I-O-N. The teacher will read it at motion, give him full mark. So that is the status now. You try to mug up and then do it without understanding anything. If you make a small effort in understanding whatever you read, you will go places. There is absolutely no reason why you cannot perform well in the life. So this is one of the very, very important message that I want to share with you all, mostly because we all know in many engineering institutions, many universities, you have to only study for just 3 months or 2 months. Somebody says even 1 month, I don't know. You have to study for just 2 months or 3 months, mug up everything, you can even get distinction. Because they ask only that, what is there in the textbook, what is done in the class. And such engineers no use for modern India, for tomorrow's India. We want somebody who is posed a problem which he has never faced in his life and he comes out fantastically with a brilliant solution. So we want such engineers, and that means you have to make your mind, yes, I will start solving problems and then start working on it. I am sure you will do very well in your all your exam. Automatically you will do, because you have understood everything. You will do very well. You will see a complete change in the way you are able to approach any subject. So that is what I want to share with you. Now let me just stop at this point because I want to take some questions from you. If you have any point or something which I have not explained properly, feel free to tell me. I wish all of you are here so that I can interact closely with you. It doesn't matter. Even if you have some questions, you can mail it to me. Later on, I will try to answer you. Go ahead. I almost see no questions. That means everybody understood everything. That's how I look at it. Okay. There could be another possibility. Is there a question? Okay. There could be another possibility. What a question. Any question, please?
Okay. Good morning, sir. Morning, sir. Sir, my name is Sananda. I am from Maharashtra, Andhra Pradesh. Okay. Sir, explain the difference between partition, coordinate.
The audio is very bad. I am not able to hear you well. Can you repeat the question, please? I know, with all technology, this is a major challenge once more. But I think it should be possible. You put in chat mode if you want. Huh? Question. You can type the question so that I can check that and then try to answer. Please put it in words. In the meantime, anybody, you have got, those who have got better audio can ask questions. There is a question? Yeah. Please, go ahead. Please ask questions which I cannot answer. That is very important, yeah.
Explain the Coriolis force again clearly. I could not understand it.
Say again, please. I got only the last part.
Coriolis force, sir.
Yes.
Please explain it again.
Once more. Okay, I will explain. Coriolis force is due to the frame of reference itself. If you are in a rotating frame, the rotation is possible only with acceleration. You have to have a circular motion. For any circular motion rotation, you require a centripetal acceleration. So a rotating frame is an accelerated frame. Because it is an accelerated frame, if you live in that and if you don't recognize that you are being accelerated all the time, that is what is happening to all of us. We are on earth, we think we are stationary, very stable in one place. You and I know, if you calculate the velocity with which I am moving, if you, by knowing the radius, omega r factor, omega you know, the time period of the Earth's rotation we know. So from that you can actually calculate what will be my instantaneous velocity, your velocity, everybody's velocity, table, chair, all of them. We are all moving in a rotating frame. Because we are in this rotating frame and we don't recognize there is a rotating, we are in the rotating frame, we find some fictitious force. Any object which is should be traveling along straight line, go in some curved path, like I showed in the case of the rotating disc. So the person on that disc will see that the path taken by the body is in a curve. It is only along the straight line for a person on the inertial frame. So there is a difference in the perception of the person who is on the rotating frame and the person who is outside. This difference comes because the difference is attributing the person on the rotating frame is attributing this additional force, due to which he finds that it is traveling in a curved path as due to a fictitious force, which we call Coriolis force. So the same Coriolis force, even though I say it is a fictitious force, is real for us on earth, because earth itself is a rotating frame, and so when a wind comes from the southern hemisphere to the northern hemisphere, it is not going in straight line, but it starts curling. Similarly, anything coming from the northern hemisphere is also turning. So this turning path is real for us on earth. So we attribute that to a Coriolis force because we are on a rotating frame. I hope I have explained a little extra. So it depends on the magnitude of the velocity and the angular velocity, omega. 2 v cross omega is the component corresponding to the Coriolis force. Is it okay? Yeah. What is the difference between polar coordinates? Okay. What is the difference between polar coordinates and Cartesian coordinates? What is the difference? There is no difference. This is one way of looking at the world. This is another way of looking at the world. Now, why do we have two viewpoints? We have to have multiple viewpoints. Because in some problem, if it involves circular motion, there is no point in solving the problem using x, y, z, because it is not suited for a circular movement. If I go to polar, you will find the problem can be solved very easily. This approach to the problem becomes much simpler if I use the most appropriate coordinate system. Now tomorrow we will go into rectangular, that is cylindrical polar coordinate, and also if time permits I will go to spherical polar coordinate. Then you will find you can have different kinds of coordinates depending upon the symmetry of the problem. Symmetry of the problem is rectangular to x, y, z. If the symmetry, if I am talking about finding the surface area of a cylinder, find in using x, y, z, I will get very complicated. I can find solution, but it will be much more complicated. But if I use cylindrical coordinates, I will find the problem is very, very simple, direct. If I have a sphere, I want to find the volume. There is no point in using x, y, z or cylindrical, but you have to go to spherical polar coordinate. Then you find it becomes much easier to handle. Luckily for us, rectangular coordinate, cylindrical coordinates, and all are orthogonal coordinates. That means what? The three variables that I am using are all the unit vectors along those directions are still at right angles, just as you have in the x, y, z system. X, y, z are three mutually perpendicular. Similarly, E rho, E phi, E z or E r, E theta, E phi in the spherical polar are all rectangular orthogonal, and therefore they are reasonably simple to work with. So there are other coordinate systems like hyperbolic and elliptic and all that we will not discuss. In certain specific problems you have to use such coordinate system. So depending upon the symmetry of the problem, you have to choose proper coordinate system, then the solution of the problem becomes rather very straightforward and simple. I will certainly show some problems based on this, and it may be in the tutorial sheet, or if there is time I will discuss while I do the course, so that you will be able to understand different kinds of coordinate system and what is the advantage. Okay, I hope I have answered your question. Is there anything else? Okay, thank you very much.